Pyrex is an idea cooked up by the wife of a glass industry scientist in 1913. She believed the tough glass used in lantern globes would be great for baking cakes in, so she baked one in some glass her husband brought home. The cake was a hit, shattering the notion that glass was too fragile for the oven. Today, you'll find glass cookware of various shapes in most homes, a true recipe for success. To whip up some dishes, a batch feeder pushes ingredients into a big furnace as they spill out of a bin overhead. Silica sand is the biggest part of the mix. It's a crystalline substance and it makes glass transparent. The batch also includes soda ash and recycled glass. Some of the other ingredients are a trade secret. The furnace heats the mix to the melting point, over 1500 degrees Celsius. It turns into molten glass that looks like lava. The glass, in this lava-like form, will spend up to 24 hours in the furnace. On its way out, mechanical shears cut it into gobs. The gobs slide down a water-cooled chute and drop into a baking dish-shaped mold. There are 16 molds on a rotating table. As it turns, the table delivers the gob-filled molds to a plunger, which presses them into the baking dish shape. Continuing to rotate, the table positions the molds under blowers. They cool the freshly molded glass so it holds its shape. A mechanical arm suctions up the glass dish and sets it down on another revolving table. Flames lick the glassware from burners above and below. The dish is exposed to a temperature of over 1000 degrees Celsius. This softens its sharp edges so that the rim is smooth. Next, hoses blast high-pressure air, cooling the dishes to solidify them, so that a mechanical arm can pick them up without ruining them. It transports the glass dishes to a conveyor belt. Further down, another arm feeds the dishes to a kiln, where heating and cooling cycles temper the glass. This is what gives Pyrex its strength. Now it's time to put a lid on things. A different plunger presses glass gobs into a lid shape. Every lid needs a knob, so a valve inside the mold forms it and then thrusts the lid up to be picked up by a mechanical arm. The arm flips its lid and sets it down on a conveyor belt. The lids are on the move, traveling through a tempering kiln. On their way out, a fan cools them off so they can be handled by human hands this time. Workers inspect each glass lid before packing them. On another line, there's a product that's made to measure. Little platforms lift the measuring cups to suctioning arms that protrude from a revolving silkscreen machine. A little squeegee forces enamel through a screen, printing measurements onto the cup. Over in the lab, a worker roughs up a sample dish. By rubbing it with sandpaper, he mimics years of wear and tear, but it's about to be subjected to even more abuse. He places a sharp tool in the center of the dish and takes aim with a hammer. Will it break without shattering into numerous little shards? It's a clean break, which means this dish has met the quality standards.